Okay, so let's continue with our next video in practice exam question series for AWS Certified Developer Associate exam. So let's see question number 121. A company's developer is building a static website that is deployed in Amazon S3 for production environment. So static website, so that's why they use S3. The website integrates with an Amazon Aurora Postgres SQL database by using an AWS Lambda function. Also website integrate with some database, Aurora Postgres using Lambda function. The website that is deployed to production will use a Lambda alias that's bind to a specific version of the Lambda function. The company must rotate the database credential every 2 weeks. Lambda function that the company deployed previously must be able to use the most recent credentials. So the basic ask is like how you are going to store the credentials so that it can get rotated. So straightforward answer should be we can store the credential into the secret manager. Let's try to figure it out. Store the database credential into the secret manager, turn on rotation, write code in the Lambda function to retrieve the credential. Yeah, looks okay. Include the database credential as part of the Lambda function code wrong. Use Lambda function environment, update the environment variable when new credentials are available wrong. Store the database credential in the system parameter store. So you can store, but you can't turn on the rotation. So A is the correct answer. Question number 122. A developer is developing an application that uses signed request to call other AWS services. So signed request means some kind of authentication. So when one AWS service is trying to call the another AWS service, they are doing some kind of authentication method. They are passing some kind of signature. So other AWS service will verify that signature so that they can decide, okay, I have to accept this request or reject the request. The developer has created a canonical request, has created the string to sign, and has calculated the signing information. Which method could the developer use to complete a signed request? So basically, they want to figure it out because now one service application trying to call the AWS service, and they should pass the signed request. So they already created a signed request. All right. Uh, Now the developer want to complete. Complete means where actually they can put this signed information. So generally we can put in like a header. So add the signature to an HTTP header called authorization. So that is authorization header, looks correct. Add the signature to session cookie. This wrong's wrong because if you are accessing your websites, then the session cookie will be helpful. But if you are accessing AWS services, this is not the option. Add a signature to an HTTP header that is called authentication. So A and C look same except they mention authorization and authentication. So the correct answer should be authorization header, not the authentication header. Add the signature to a query string parameter that is named X Amazon signature. That is also correct. If you noticed, when you store any object in S3 and if you want to temporarily give the particular object access to someone else, so you create a pre-signed URL, and in the pre-signed URL, within the URL itself, you pass the token, or you can call it as a signature. And when you pass the token, you mention like X Amazon signature equal to something like that. So you can pass as a query parameter. That is also one option. Add a signature to an HTTP header that is named www authenticate. So www authenticate again for the website, not for the AWS service. Even if you go with the elimination approach, so session key wrong, authentication wrong, and www wrong. So remaining option is like authorization and X Amazon signature, A and D. Question number 123. A company must deploy all its Amazon RDS DB instance by using CloudFormation template as part of the code pipeline continuous integration, continuous delivery automation. So they want to deploy the RDS database using CloudFormation, and the CloudFormation is deploying using code pipeline. The primary password for the database instance must be automatically generated as part of the deployment process. So they said, because when you create a database, you should have the password to generate, right? Username and the password. So they said you need to automatically generate the password as part of the deployment process only. Which solution will meet this requirement with the least development effort? Create an AWS Lambda backend CloudFormation custom service. Write Lambda code. So this is not a least development, right? So you are writing a code, so this is not a least order. So you can directly eliminate even without reading the full option. Use the AWS code build action of a code pipeline to generate a secure string using command AWS secret manager get random password. Pass the parameter into CloudFormation template with no equal attribute set to set the parameter reference to create the DB instance. Yes, you can do that. You can add a one more stage that is a code build. So you can create a code build project. You can pass that stage to the code pipeline, and that is going to generate a password, and you can pass it to the CloudFormation without printing it. So you can set no parameter. But now you pass it, but where you are storing it, right? So you created it, but you are not storing it anywhere, right? So if once the database has been created, how you know which password it has created? Because it is a random password, which password it has created. If you have to access the database, you should know the password, right? So you are not storing it anywhere. Also, you are maintaining a separate project called build. This will work, but not a good solution. Use AWS Lambda backend configuration. So again, not a least development effort. And use the AWS secret manager secret. Yes. So if you use this in your cloud formation, this is going to generate a secret. So you can generate a secret. You can store the secret into secret manager. Yeah, that's a better option because once, so you can generate the secret. That secret can be used. Basically, you generate a password, which is secret. That password will be set for the database, and you also store into the secret manager, which will be going to use in the future as well. So D looks correct. Question number 124. An organization is storing a large number of files in S3 and is writing a web application to display metadata about its file to end user. So there are so many files in S3 and metadata they are displaying to the end user. Metadata means like maybe the name of the file, the timestamp of the file, size of the file. Correct. Based upon the metadata, a user selects an object to download. The organization needs a mechanism to index the files and provide a single digit millisecond latency retrieval for the metadata. So basically this metadata should be stored somewhere. So which database they can use? Uh, because it's not a structure data, many metadata information can be stored. Some files may not have that information. So you can use DynamoDB and RDS both, but not EC2 and Lambda. But the question says it should provide a single digit millisecond latency, which is going to provide by the DynamoDB, not by the RDS. So A will be the answer. Question number 125. A developer is creating an AWS serverless application model template. So SAM template. AWS SAM template contains the definition of multiple AWS Lambda function, S3 bucket, CloudFormation. So SAM template is basically used to deploy same as a CloudFormation template, but it is specific for the to deploy your serverless services like Lambda, S3 bucket, CloudFront. So they are deploying it. One of the Lambda function runs an Lambda edge in the CloudFront distribution. So they are deploying multiple AWS Lambda function. One Lambda function has a Lambda edge function. The S3 bucket is configured as an origin. Okay. When the developer deploys the SAM template in EU Western region, so Europe region, the stack creation failed. So what will be the reason? So if you create S3 bucket, it can create it in EU West one, no issue. If you create a Lambda, it can create in EU West region. CloudFront is a global service, so you can deploy it from any region, which looks fine. But I think the problem is the Lambda edge because Lambda edge should be created into the US East 1 region because the Lambda edge is associated with the CloudFront distribution. If you created this function, because CloudFront is a global application, and if you created this function only in a specific region, then how you are going to attach this function with a CloudFront? Right, because CloudFront is a global service and this function only available in one region, so it should be in the US East one region, so that you can attach to all the CloudFront. So CloudFront distribution can be created only in the US East one region. Wrong, CloudFront is a global service, so you can deploy it from anywhere. Lambda edge function can be created into the US East region. Yes, this can be the issue. So you should create in US East region rather than the EU West region. A single SAM template cannot contain multiple lambdas. Wrong. A template can contain multiple lambdas. A CloudFront distribution S3 bucket cannot be created in same region. Wrong. So S3 bucket and CloudFront distribution can be created in same region. So C and D totally wrong. So out of A and B, B is the correct answer. Question number 126. A developer is integrating Elastic Cache in an application. The cache will store the data from a database. A cache data must populate real-time dashboard. So you have a database, you are also using the cache. So cache is storing the data from a database, and the cache data must populate real-time dashboard. So which caching strategy you will do this? So there are a lot of caching strategy. As an example, when you are trying to write something, so you this is your application as a point A. In middle you have the cache, and in the backend you have a database. So one thing is, you can update the cache first, and once the cache has been updated, then you can update the database. All right, this is one thing. The second thing is, you will first update the database and then update the cache. So that was the best solution, because if you update the cache first and cache get updated, but when you are going to update the database, let's suppose the operation is going to fail. So it means database not get updated, but you have the data in the cache, and user will get the data from the cache even though there is nothing in the database. All right. So generally it is prefer first update the database, and once the database has been updated, then update the cache. So there are like different strategy. Read through cache. Read through cache means when you are trying to read the database, read it from cache. So first read from cache and then the database. Right behind cache. Right behind cache means first like cache will be updated, then whatever is behind after the cache, then that will be updated. So that is wrong. Lazy loading cache also like wrong. Right through cache is like correct. uh, so you will first update the database and then update the like cache, so for the real time dashboard. Otherwise uh, the values are not in the database but in the cache. So if you go to the discussion tab, so I have like mentioned here, in a write through cache code, every write operation for database is immediately mirrored in the cache. This ensures that the cache always contains the most up-to-date data and ideal for scenario where real-time consistency is required, such as updating dashboard. So question number 127. A developer is creating an AWS Lambda function. The Lambda function needs an external library to connect to a third party. The external library is a collection of files with the size of 100 MB. The developer need to make the external library available in the Lambda execution environment and reduce the Lambda package. So that is a simple solution. You can use the Lambda layer if you are using external library, and you feel the size is very large and you want to reduce the Lambda package size. You can like create a Lambda layer. So let's see. So create a Lambda layer to store the external library. Yes, that should be the answer. Even I don't need to read the other option. S3 bucket wrong, temp directory EFS wrong. So A will be the correct answer. Question number 128. A company has a front-end application that run on 4 EC2 instances behind a load balancer. So your application is running on EC2, but uh, access using load balancer in a production environment that is provisioned by Elastic Stack. So these EC2 and load balancer are provisioned using Elastic Stack. The developer need to deploy and test new application code while updating the Elastic Beanstalk platform from the current version to a newer version. So they want to update the Beanstalk platform version, some to new version of Node.js, and they want to test application code. The solution must be zero downtime, and they want it should be zero downtime. So the existing, because it is a production environment, existing users should not be impacted. So which solution strategy will you do? clone the production environment to a different platform version, deploy the new application code, test it, swap the environment URL upon verification. You can do this, but once you swap the environment URL, uh, right, so at that time, a minimal, like you have to give the new URL to the user, right? Then there might be downtime. Deploy the new application code in all at once deployment. That is totally wrong. All at once means a huge downtime. Perform an immutable update to deploy the new application code. That looks correct. Immutable update means don't touch the existing EC2 instances. Deploy the new version into the new EC2 instances. And when the new EC2 instances are healthy, so once they are like health checks has been passed, serve the traffic to the new health one. So C looks okay. It contains zero downtime. Use a rolling deployment for the new application code. Rolling deployment also ensure zero downtime, but it doesn't guarantee that the zip data. So C will be the answer. Question number 129. A developer is creating an AWS Lambda function. The Lambda function will consume message from the queue. The developer want to integrate unit testing as part of the function CI/CD process. So how can the developer unit test for the function? So you have the Lambda function which is consuming some messages from the queue, and you want to perform unit testing like as part of maybe CI/CD pipeline, right? Okay, let's see. Create a AWS CloudFormation template that create a SQS queue Lambda function are totally wrong. Like generally when you do the unit test, you should not create the actual AWS sources wrong. Create an SQS event for test. Use a test that consume the message from the SQS queue during the function CI/CD process. So this is the integration test, not the unit test, because you are integrating Lambda and SQS queue. Unit test means you can just pass the required input to the Lambda function. Create an SQS queue for test. No, just use the AWS Lambda invoke command by passing a test event, which exactly same as what exists in the SQS queue. So that will be the unit test. Just testing the Lambda. D will be the correct answer. Question number 130. A developer is working on a web application that uses Amazon DynamoDB as its data store. So web application is storing data onto the DynamoDB. The application has two DynamoDB tables, one table named artist and other table named song. So you have two DynamoDB table, one is artist and one is song. The artist table has artist name as the partition key, so maybe the primary key. The song table has the song name as the partition key, primary key, along with the artist name as the sort key. The table usage pattern include the retrieval of multiple songs. So they want to retrieve the multiple songs and artist in a single database operation from the web page. The developer need to a way to retrieve this information with minimal network traffic and optional application optimal application performance. This solution will meet this requirement. So you have two tables, so you need to find a way you can get the data from the two tables without impacting any performance. So perform a batch get item operation that returns items from the two tables. Yes, batch get item operation. Using the batch get item, you can retrieve the data from the two tables. Use the list of the song name, artist name key, song name, and the artist name. Song name and artist name for the key for the song table, and the list for the artist name key for the artist table. Yes, you can do that. Create a local secondary index on the songs that use artist name as the partition key. Perform a query operation. No, you don't need to create a local secondary index or anything like that. You already have the required information. Uh, Perform a batch get item operation on the song table that use the song name and the artist name key. Perform a batch get item operation on the artist table. You can do this, but if you see, you are performing this operation twice. One is here, batch get item, one is here. So that is not a optimal application performance. Perform a scan operation. Totally not recommended. Like you are scanning on the whole table. So A will be the correct answer. So that's it. That's the end of the video, and thank you.